Alright, howdy everyone. I just pulled these heat sinks out of this UPS, to free up the FETs. And so the order you have to go about this, I'm sorry for the dark video, is there's these screws that they use to hold in, let's get it here, hold in the FET into the heat sink. And you need a 2mm Allen key. And you're going to find they're really hard to start. They're really hard to turn. And sometimes even to get the Allen key in there. And so yeah, you're gonna have to do most of it with lots of leverage, with the Allen key giving you lots of leverage, and in the last 2 or 3 turns you can spin out with your fingers. And so basically you come and get this in a shot here. You pull the first 2, then you desolder, you pull the next 2, desolder, and you just walk your way down. And what I found was let me focus this. There you go. There are these kind of feet, these spring-loaded feet that go through the bottom. And you heat this up, get it all nice and molten with your soldering iron, and then you give them a pinch with pliers in your other hand. It's quite the balancing act. And then these will be loose enough that you can wiggle out one side, heat the bottom edge, and pull the thing out. But I mean, I'm a relatively experienced solderer. I build circuit mount boards quite, every few months. And this job took me an hour and a half, an hour. So it's pretty tricky. Just be careful, you don't want to damage anything. But yeah, so the next couple of clips, I'll probably have bought these wires are blocking them, more of these capacitors. I'll try and find some more of these, and we'll get back to putting this thing together. All right, enjoy. All right, everyone, here we are now, well into the reconstructive process. I've added all the FETs, so you can see we're up to 16 from 8. I've added these small little film capacitors in here, and if you look closely, you can see I've also soldered in the 20 ohm resistors so that all the FETs are being driven. So I just wanted to show you guys my process here for reassembling these. I went to the hardware store and got some number 2 screws. I think they're 3/8 long, and then the little nuts that go on them. And I ordered some solder paste off Amazon, and I'm just going to put a little dab of solder paste on each one of these to increase thermal conductivity. And I was a little bit concerned about maybe that impedes the conductivity, because this back tab is conductive and so is this heatsink. It's carrying current, but I figure that the screw is gonna be more than fine, and I'm not gonna go very heavy on the solder paste. So, oh, and you gotta do these one at a time. So I lined this one back up, soldered it in, but in order to access these screws and stuff easily, I'm just fully finishing this one before I put the remaining heat sinks in one by one. Alright, there we go. That is all 16 screwed down, thermal pasted, you name it, ready to go. So I think I'm going to go ahead and put some thermal paste on the bottom of the transformer and then start putting this back together. Alrighty, so you can see, exactly like you're not supposed to do on a computer. And just globbed a bunch of solder paste in here to take up that little bit of gap. And I cleaned off the bottom of the transformer and the case before I did that. So I'll get this bolted back in, see how it does. Alrighty, so we can see I just test fit the transformer. You can see the pattern on the bottom. So I was getting decent contact at the far end, but I think I need to make the solder paste, add some more goopage in here, see how that works. Alright, well that's that put back in. It's set real nice. As I set it down, you can kind of feel the solder paste slide out. Now it's time to put the circuit board back in and see sparks fly. I mean, watch it work perfectly the first time. Alrighty, slight intermission. That was a little uneventful. I had to add one of the mounting screws back to the main board so that it would be grounded to the chassis. Let's go set ahead and see what happens. If it runs its inverter test, is probably gonna overdraw the power supply here. But at least that all seems to be working correctly. Blinking the front panel lights across the board there. So I'm gonna turn off and see what's what. Alrighty. See if we can get this thing to turn on a power supply. Alright, here goes. Alright, it woke up. It's drawing about, you can see 1.5 amp. Everything looks good, at least to start. An interesting finding here is I believe we were getting around 3 amps charge rate before. And now that we've doubled these MOSFETs, right, I've got my meter zeroed, and you can see we're getting almost 6 amps. It was 6 amps a second ago when I first started. And I think that has to do with the way this charging circuit works is they use the body diodes in the H-bridge as a rectifier. So by doubling the amount of diodes we have, we've just increased that, or diodes in parallel, we've increased that capacitance. Very cool.